Hello all, and happy to be back speaking to JSLA. It's one of my favorite meetups. I always look forward to getting with this group and talking about what we've been working on with Node. So yeah, as David said, I'm a Node core contributor. I recently did join Cloudflare. I'm in my third week right now, so still brand new, still assimilating everything, but have some really good things in mind, some fun plans that all line up with a lot of the stuff that I've been doing with Node for the past couple of years. So things, web platform standards and streams and quick and all of these things are things that I'll also be doing over there. So I'm excited, maybe come back and talk about some of that stuff. But today, we're talking about the readable streams implementation that just landed in Node in, I think it was early July. We got this implemented and landed. And when we're talking about this new streams API, we're talking about the same readable stream, writable stream, transform stream that you have in browsers that you can find in Deno. You can find in workers. This is getting to be a very ubiquitous API. If you're using Fetch, the Fetch API in browsers at all, the readable streams API is what you're using there to consume that data. Now we'll talk about the APIs a little bit. I'm going to talk about some of the utilities that we added to kind of go along with this. So some parts are standards, some parts are Node specific, and I'm going to kind of show how some of those things work. But I do want to touch on one thing right from the start. Literally no one wanted to implement another streams API in Node. I mean, this is just the truth. There's if you're not already aware of the background, there's already 3 streams implementations in Node. Now they're all wrapped up in the same set of APIs. This requires stream module, and you have the readable and you have the writable. Right, these classes that have been there in Node for forever. If you want to read file, you use fs.create read stream. These things have been there, but there's 3 different versions of those API of that API layered into the same set of objects. Right, streams 1, streams 2, streams 3. I don't want to go into all the details of this, of those, but the implementation is very complex. And it's rooted in a lot of the original fundamental API concepts that that Node is based on. So you have like event emitter, you have callbacks, you have this fairly complex state model for managing the queue internally, and it works great. As David was saying, it's one of the best and least understood features of Node, simply because of how you can structure data processing pipelines efficiently to operate on huge amounts of data very, very quickly. But it's also it's very Node specific, and when browsers started looking at it needing to process streaming data, they chose to go a different way. If you're over in Deno using that, you're going to be using streams a different way, and that different way is readable streams. And it just got to the point where with Node, we couldn't push it off any longer. There's, folks that have been asking us to implement Fetch, the Fetch API for a while. And the one thing that was really stopping us, really getting on our way from doing that, was the lack of a readable streams implementation for Node. So earlier this summer, I said, screw it, let's just do it. And we implemented and landed the readable streams API. So that's kind of the background. So let's see what it looks like. All right. So if you've seen readable streams in the browser, this is going to be immediately familiar to you. If not, I kind of want to talk through it a little bit. The one thing that we are doing differently than the browser is that the readable stream is not a global yet. You do have to import it from the stream web core module. If you see here, I'm using the ESM syntax. If you're using CommonJS still, you would just translate that to a const readable stream. You would require stream web. Okay, so if the syntax here looks a little different, it's because I am using that ESM, the MJS format. All right, so from there, we create a readable stream. Every readable stream has what's called an underlying source. The underlying source is wherever that data is coming from. If the stream was created by nodes and internals, then that underlying source is hidden from you. You're not going to see it. That might be coming from the file system. It might be coming from the network, whatever. But it's also possible to create a stream with a custom underlying source. And this is where essentially users can create their own instances of these and hook them up to their own sources of data, to pull data from wherever. So if you're mapping from, some, proprietary API or company API, whatever, and you want to expose that as a readable stream, you can implement this source yourself. I won't go into all the details of the API here. You can go out to the MDN, Mozilla Developer Network, look at readable streams. Here's the nice thing, it's the exact same API. You don't have to go just to the node docs to figure out how to do this. MDN docs will tell you how to use readable stream, and it works the exact same way in Node. So here, right when we're starting our readable stream, I'm going to include two chunks of data. And then I am just going to use an async iterator to consume this, to read those back out, and to read that data out. Now to see that in action, it's super simple. I can just come up here and run this, and oh, we got the hello world. We see it just works. It's working in Node. Let's see, I'm using an experimental version of Node right now. Let me just see which version I have installed, just to show you that it works in the version that you can install. Oh, there's no. Okay. So if you install Node 16.8, readable streams is in there, and you can make use of them today. It's been, I think it went in like 16.5 or something like that earlier in July when that actually was released. So it works. We can create a readable stream. We can put some data into it. We can read it back out. Same Stream API available most browsers, Dino, workers, multiple JavaScript environments. It's all there, all available. We can use it. Now, it's not just reading data, it's also writing data. You can create the new writable stream. Again, if you're already familiar with this API, this should look very, very familiar to you. If you're not, here's what's going on. The writable stream has an underlying sink. This is some object where that data is going. Right? It's the thing that actually processes the writes when it receives something. If that writable stream is created by Node and returned to you, you're not going to see that sync, but here you can create your own and customize whatever you want it to do. Very straightforward. So we're creating a writable stream, getting a writer to it. Notice the pattern is just slightly different than using that async iterator. We write two chunks to it. Notice we're using the await; those do return promises. And then when we're done, we close it. Right, and what we're doing here, all this writable stream is doing is when it receives each chunk, it's just going to go ahead and drop that out to the console. So if I switch over to the code again, and I run this example, which is the BEM.js, we'll see the same thing. We get the hello world as expected, because it's dropping those chunks out to the console. Okay, so what's going on here? Before I go on to others, this implementation, is this just a wrapper around the existing Node streams that what you had, the stream.readable? No, this is a completely different set of code. It is a full implementation of readable streams, completely independent of the existing streams API that's out there. And the reason I did not implement this as a wrapper was for performance. I didn't want to have one data abstraction on top of another data abstraction that just ends up slowing things down. Right, so this is a separate implementation. Now, what you'll find is that readable streams right now in Node is definitely slower than the existing streams API. And the reason for that is we haven't gone through and implemented all of the performance optimizations that we could implement, and that we have implemented for regular streams. An example of this, it is possible within certain parts of Node that if your data source is coming from the native layer, like from the file system, and your you want to pipe that to another a writable stream, which is also connected to the native layer. Say it's going out to the network. There's things that we can do within Node to optimize that data flow. So all of the data transfer happens at the system level, at the C++ level, rather than up in the JavaScript, and it makes it significantly faster. That works for parts of the existing Node streams. None of that is implemented for the readable streams yet. So all the data that's going through the readable streams, writable streams, is happening all in JavaScript using this, using a standard flow. So it's a little bit slower for now. I do have plans to go back and implement a lot of performance optimizations to make it faster. So if you want just raw performance, if you're looking, and you have a lot of data to process, I probably still recommend sticking with the existing Node Streams API for now. And as we go, as this implementation matures, we'll work on getting those performance optimizations in there. And we might have a few other things that we add in as well. All right, so let's keep going with some of these examples. All right, so we also have transform stream support. So basically what a transform stream is, exactly what the name suggests. You're taking some bit of data in, converting it, transforming it into another format, and spitting it back out. In Node, you would do this with an object called a duplex. It's a single object that is both a readable stream and a writable stream at the same time. You write in on one, and you can read the data back out on the other. With the WebWG Streams API, it's slightly different. You have what is called a readable-writable pair, which is an object that exposes a readable property and a writable property. And those give you two separate objects. One is a readable stream, one is a writable stream. Okay. When you write data to the writable stream, that goes in, possibly gets transformed, and then you can read that back out on the readable side. Okay. So in this example, you notice that I have compression stream here. This is another web platform standard API. Compression stream exists in the browsers. I'm not sure if all browsers, but it's there. And I think at least Chrome and Firefox, I believe. But it's a standard API. It's getting implemented in a couple of different places. I know it exists over in, I believe, Dino as well. So a compression stream, what it does is it can take the data being written in, and using either gzip or deflate, it can compress that, and then there is a corresponding decompression stream, which will decompress the data being written in. So in this particular example, I am writing in two large chunks where I'm repeating hello 100 times, then repeating world 100 times, passing that into the writable side of this compression stream. And if you see here on this output, I'm using the async iterator to read that back out, to consume that back out. And what I get back out is a much smaller set of data encoded into uint data arrays. And this is the gzipped representation of the hello world content. So if you're already familiar with Node, we have gzip streams. We have deflate streams already. If you go to the zlib module, all of that that's there is based on the existing Node API, stream API. Compression stream, decompression stream, give that to you in this web standard API. Okay. And if you want to see that work, now one thing that about the compression streams is this is not yet shipped in a Node release. Hopefully, it's coming soon. But you can see that yes, it actually does run when we pass this into Node. All right. Okay, so what's another transform stream that we have? One that is very common to use, and if you're familiar with the Fetch API, this is one that you've definitely seen before. It is the text encoder stream, and there's also a text decoder stream. And basically what this is, is just either taking string data and encoding it as UTF-8, as a set of UTF-8 bytes, or taking some encoded set of bytes. It doesn't have to be UTF-8, It can be any of the it's a wide list of supported encodings, taking those streams, those arrays of bytes, and decoding them into strings, or encoding them into strings. So again, it's just a transform. We're writing to the writable side, we're reading it from the readable side, and and the data is transformed there in the middle. All right, so in this case, we see that we're writing the hello world again, and we get those out as uint data arrays with the encoded bytes. All right, nothing fancy. The API is designed to be as straightforward as possible. This exact code will work in the browser. You just have to take off the import statement here. You can drop this into the browser and it will just work. All right. Or if you wanted to, create code that runs both Node and Deno, go for it. This will just work in either case. Okay. Text encoder stream is available in a release. It's out there now. Now, I will stress all of these APIs are still experimental. Whenever we introduce a significant new bit of functionality like this within Node, we always mark it experimental for at least a few months, even if we don't expect it to change at all. The implementation of these APIs is feature complete. We have implemented the entire spec, and we run the web platform tests to validate that we're doing it correctly. And we are. We pass all those tests. We've implemented the whole thing. There's nothing here that we're looking to add or change. So, the API is stable, right? It shouldn't go away, but we're still going to mark it experimental just in case we got something wrong and we have to go back and fix something. And it's possible it might be that those fixes might be might break backwards compatibility. Things that are marked experimental in Node do not have the same semantic versioning rules. So whereas a fully supported API, say like the old streams, right? When you want to make a breaking change, that has to be a semver major, and we have to run all kinds of extra tests and smoke tests on the ecosystem, make sure things don't break. If it's experimental though, then we can make breaking changes anytime we need to while it's experimental, while it's still being developed, but we'll still get it out there as quickly as possible into the ecosystem for folks to use and test. So readable streams is going to be experimental for a while. There will be some parts that take a little longer to get out into a release, but this stuff is coming. Okay. Okay. So moving on. All right. So we can use the text to, so far I've been using streams that we've created, right? They have this, just doing simple stuff like hello world. What if we wanted to do something more interesting and much more common, right? Let's read a file off the file system. Before, you would use fs create read stream. And what that would do is give you this, this old style Node streams readable, where you can, pull in that data. But, we are developers who are interested in cross-platform compatibility. We want APIs that will work across multiple environments. We want to use promises. We want to use the standard ways of doing this. So here's the new way of doing it. We have import open. This is from, this is a method within Node that allows you to open a file using a promise API. What you get back is a file handle object. Here we're going to create a text decoder string. And we're going to use an async iterator to read the file content. So see this pattern, file.readable web stream pipe through. That readable web stream is the pattern that you need to pay attention to. Within Node, in order to avoid confusion, because we have a stream.readable object and a readable stream object now. On the web APIs, the convention is to use like a .readable property. And that will always give you like a readable stream. But in Node, it gets a bit ambiguous and confusing. If you just see .readable, you don't really know what kind you're going to get. So the convention we've settled on within Node is that we want, instead of having just a .readable to get a readable, the standard readable stream, we're going to use this .readable web stream. And then if you see a corresponding readable node stream, that's how you'll be able to tell the difference between what you're getting. So if you see on an object, if you want to know if you can get a readable stream from it, look for that readable web stream method. So far, it's only on the file handle, right? But we have some other APIs that are coming later. For example, the Quick API that I'm working on will also have built-in support for using the standard web streams, and you'll see this readable web stream method there as well. All right, so here, again, this example, it's reading the file content, right? We're using the text decoder stream to just convert that, because if I didn't use a text decoder stream, then what the chunks what I'd get back would basically just be uint8 arrays or array buffers. It's just those byte objects, and that's not what I want. What I want to do is see the text, right? And I want to consume this as text. So with the text decoder stream, I put that in there, pipe it in, get the data off, and when each chunk of data that is written will be converted to strings, and I can consume them that way. So here I'm just jumping them out to the console. So if I wanted to see this in action, it's very simple. I'm just going to get the, I'm reading one, a.mgs here, so it's a different file here, but you see, you get exactly what you expect of the console. All you're doing is getting the contents of that file dumped out, right? Very simple way of reading the file. But what if that's a lot of boilerplate to go through for every time I want to read a file, right? Anytime I want to, process, some stream of some text, it's a lot of boilerplate that, I don't want to have to rewrite this every single time. So we decided to make it a little bit easier. And this is a node specific utility, what we call the streams.consumers module. Now it's not in a release yet. Hopefully it's coming to a release soon, right? But what it does is give you a certain set of methods for consuming streams in common ways. So that previous example where I'm taking that file content and using the async iterator and piping it through the text decoder stream to get the contents, I can replace all of that boilerplate with a simple await text and pass in the stream. So here again, I'm getting the file handle. I get the readable web stream. In here, I pass that to text, await, console log, it works, right? So let's go over, see that. If I just run this example here, there, it just works again. All right, so these utilities are designed to eliminate boilerplate. Now, there's several of them that we have. We have a function, an array buffer, that returns the stream content however long it is as a single array buffer. We can return it as a blob object, which is another web platform API that we've implemented recently with the Node. You can return it as a buffer, which this is the Node buffer that's been there forever. You can return it as text, and you can also return it as parsed JSON. Okay, so what basically that parsed JSON will read it in as a UTF-8 string, and then parse it through just run through JSON parse. Right, pretty simple. Now, if these methods look familiar, with the exception of blob, array buffer, blob, JSON, and text, if these look familiar, they should, because if you're familiar with the fetch API, specifically the body mixin, so these are the methods that you would use on the response object in fetch to get the contents of that response. These were modeled directly off of those, and were designed to be part of the implementation of a fetch API. All right, now I have, there's something, we'll say a little bit later, folks have been wanting fetch to come to Node for a while. And I'm happy to say, I'll show you how we've done it later, that we do have a fetch implementation for Node now. And it's officially part of the Node project. It's not in Node Core, right? But I'll show you how we get there. But we do have a fetch implementation. It's still experimental, but it does work. All right. All right, so let's talk about one of the other useful utilities that we have. As I mentioned earlier, readable streams is not an adapter for regular streams, right? But what if we do want an adapter for regular streams, right? So here we have a handful of these. We have the to web, from web on the static methods on the readable, writable, and duplex objects. And what these allow you to do is convert a node stream to a readable stream, or a readable stream to a node stream, right? They allow you to go back and forth. Now these are adapters. So it will wrap, the node stream in the readable stream API, or it'll wrap the readable stream in the node stream API. And you can consume them correctly with either model. So if you have an existing API that is based on node streams and you want to use it as readable streams and you don't want to have to rewrite everything, and then you're going to use these adapters. Now, I don't think I'm not sure if the adapters have landed yet in a release. They will be coming very, very soon. Okay. Now, some things to keep in mind before I wrap up. Like I said, they are kind of slow. We have not implemented performance optimizations for them yet. They are not globals yet. You have to import them from the stream web, stream consumers, those modules. And the reason they're not globals yet is, remember, they're still experimental, they're stable, but we don't want to expose them as globals until we're ready to graduate them. They do pass the web platform tests. Fantastic. It's good validation. And the most important point here, nothing of this talk should you interpret as node streams going away. They will not be deprecated. They are not being removed. I don't think they will ever be removed. These two streams APIs will continue to coexist indefinitely forever. All right. Now, one last thing before I wrap up, but I want to point out the Node Undici project. This is a separate module that you can install. It is developed under the Node project, so it is an official Node project. It's just not part of Node Core. This is a new HTTP client for Node that implements fetch to the standard, to the specification. So there are some differences, like there's some garbage collection and things, it's some state management stuff that's slightly different because it has to be in Node. But if you want a fetch API that is spec compliant, that uses these mechanisms, these built-in web streams from Node, and some of the other things that we've implemented recently, like Blob and that kind of thing, then Undici is what you want. And the goal, ultimately, we're still figuring out the details, would be to pull Undici into Node as a vendor dependency and expose this as the official fetch implementation. So if you want to get a start on using fetch with Node in a way that is going to be forward compatible with where we're going, then Undici is what you want to use. And that's it. So that's a quick overview. I'm happy to answer any questions. We can go into a lot of detail. I love talking about this stuff, so feel free to reach out.